Right, because if, right.
How'd you get the 1.5869?
How did you?
I think when I did it, I rounded, because I was rounding
No.
when I did it. I'd have to look at it.
Okay,
I did it.
okay.
I
Yeah,
got the right answer, so.
the point is, she did it a little different way, and probably what she ended up doing was she ended up coming up with the present value factor and went to the table and found out what percent that factor falls on under.
I took the 10,000 and I took 8%, and I took times 1.08 to the 6, and I took 10,000 times 1.06 to the 6.
6, okay.
So I did it backwards.
Okay, she did it backwards to get the answer. You know what? Getting the answer, that's okay. However you get the answer, that's fine. That's fine. That's right.
But I got the right answer. You just look at the answer that way.
You know what? However you get the right answer, that's okay by me. Whatever works for you. Okay, she got the right answer, so she's happy with it. So basically, she's looked at the present value table to get it. Yeah, which you can do. You can always use those tables, and then once you, sometimes what I'll do is if I'm not sure, I'll use a present value table. I'll find out what the present value is. Then I'll go back and plug in the formula, make sure that it works, and it does, and then I know I did it right. So you could do that too. Whatever works. Okay, now we're jumping over to slide 15. $332,000 today at 6% to fund the project. This investment will fully fund the project in approximately how many years? What their present value formula. Okay, how do I know that? Because remember, the future value is 50,000. The present value is 332,000. What are the other two factors in this formula? Is the percentage rate and the number of years. So you could have used the future value or the present value formula, it doesn't matter which, but you want to solve for n, which is the number of years. I picked the present value formula. So I took and rearranged 6 to the unknown nth power, and then I took the 500,000 divided by the 332,000. And that gives me 1.06 equals 1.506 over 1 to the n. Then I went to the future value table to find out what year the future value of 1.506 appears under the 6% column. So you find the 6% column, find out where this 1.506 is, it'll tell you how many years. And they found out that it's 7 years. Okay? That's the only. And there might be another way to do it, but that's what worked for me. Okay, again, it's just a matter of algebra, trying to flip it over. And remembering, when you go to those future value tables, that it tells you, that's what it is, just 1 plus r to the n is what those future value tables contain. So you have r, you have n. So if you have a future value number and you know r, you can figure out n. Same thing vice versa. If you know n, you can figure out r. Okay? Okay, so now we're going to go to question 16. No calculations on question 16. Yeehaw! Which one of these statements regarding the frequency of interest compounding is most correct? And the answer is D. The more frequently interest is compounded, the more quickly the investment principal increases. That was slide 12, we talked about it. So those are the times when you have like a semi-annual interest rate, it pays 6% twice a year. And that's why, too,